Welcome to Mathematics Lecture Series, lecture number 7 in Applied Calculus Series. Circular and hyperbolic functions I discuss in this class. For the start of class, I request you kindly subscribe the channel to click the bell icon and like the video. Circular and hyperbolic functions. Trigonometric functions are also called circular function because it satisfies the equation, this circle equation x square plus y square is equal to 1. We replace x with cos theta, y with sin theta. Then you will see cos square theta plus sin square theta is equal to 1. Since these two functions satisfy the equation of circle with origin, with center at origin and radius as well. This parameterization is not unique. Another solution also x cos n theta y sin n theta and belongs to natural numbers. Cos sin x satisfy the equation of circle. Therefore, these functions are called circular function. Trigonometric function sin x, cos x and exponential function e power x are the functions which can be expressed in infinite series of non-negative increasing powers of x. Such series are called power series. Also we sin x represent sin x in the infinite series of non-negative increasing power of x. X here minus x cube over 3 factor x 5 over 5 factor x 7 is a series of sin x. Cos x 1 minus x square upon 2 factor plus x 4 over 4 factor is 6 over 6 factorial. E power x series 1 plus x square 2 x cube over 3 factor x 4 over 4 factor and so on. We replace x by x in the equation number 3 where iota is an imaginary unit. Iota is equal to square root minus 1, iota square is equal to minus 1. So e power x replace with x with iota x1, x with iota square x, iota cube, just x replace with iota x, then you will have this series. So here is e power iota x1, the one iota square is equal to minus, so minus x square over 2 factorial plus iota cube is equal to minus iota x cube over 3 factorial plus x4 over 4 factorial and so on. So e power iota x, here we separate the real parts 1 minus x square over 2x 4 over 4 x 6 over, take the iota common from imaginary parts, so iota x second term is minus x cube over 3 factorial plus x5 over 5 minus x7 over 7 factorial plus and so on. E power iota, what about this? This is a cos x series and that is a sin x. So e power iota x cos x plus iota sin x. This identity is called Euler's identity. So e power iota is cos x plus iota sin x. Here x replace with minus x, so e power minus iota x cos x, so cos minus x is equal to cos x plus iota sin minus x is equal to minus sin x. So we have equation number 4, that is if we combining adding 4 and 5 we add 4 and 5 e power iota x right hand side add with right hand side e power minus iota x, here 2 times cos x iota sin x will be cancelled with minus iota sin, so 2 cos x is equal to e power iota x plus e power minus iota x, and if we divide both sides 2 we will have identity of cos x is equal to e power iota x plus e power minus iota x divided by 2. Similarly, if we subtract 5 from 4, subtract e power minus cos x will cancel and minus plus here this also becomes plus by the subtraction. So 2 times iota sin x. Sin x is, if we divide both sides 2 iota, we will have sin x is equal to e power iota x minus e power minus iota x divided by 2 iota. Now right, we simplify tangent. Tangent is sin x upon cos x. So what is sin x? Sin x is equal to e power iota x minus e power minus upon 2 iota. Cos x, you have the value of cos x e power iota plus e power minus iota x upon 2. 2 will cancel with 2 and we will have the tangent x in the exponential form e power iota minus e power minus iota x iota x plus e power minus iota x. Cotangent x 1 over tangent x. So just take the reciprocal, you will have the value of cot x. Similarly, sec x 1 over cos x. So cos x is 2 upon e iota x plus e power minus iota x. Cosec x is equal to 1 over sin x. So just take the reciprocal of sin x 2 iota e power iota x minus e power minus iota x. So these are the formulas, identities of sin trigonometric to an exponential. So these are called circular functions: sin x, cos x, tangent x, cotangent x, secant and cosec x, and the exponentials forms. Hyperbolic function. This is a graph of e power x, and that is a graph of e power minus x. Here, that is a graph of e power x plus e power minus upon 2, means cos hyperbolic x, and that is a graph of y e power x minus e power minus upon 2, that is a sine hyperbolic x graph. It is found that these two functions have properties which in many respects are similar to those of y cos x and y sin s. It has been known that hyperbolic function bear a similar relation to a hyperbolic with a trigonometric or circular function due to the circle. The function y e power x e power minus is called the hyperbolic cosine of x, and y e power x minus e power minus x is called the hyperbolic sine of x. Abbreviated cos hyperbolic x, sine hyperbolic x respectively. They are defined by the above equations, that is cos hyperbolic power s e power minus x by 2 sine hyperbolic y e power x e power minus x upon 2. They describe the motions of waves in elastic solids, the shapes of hanging electric power lines, and the temperature distribution metal cooling fins. There are four other hyperbolic functions. They are tangent hyperbolic x is a sine hyperbolic x, cosine hyperbolic x. So we write the value of here, replace sine hyperbolic e power x, e power minus x, e power x, 2 will cancel. So tangent hyperbolic x is equal to e power x minus e power minus x, e power x plus e power minus. Similarly, cotangent hyperbolic x, sec hyperbolic x, and cosec hyperbolic. Hence, we have 6 hyperbolic function also. These are the formulas of the hyperbolic functions. These can be expressed in the form of series also, which derived from the series of since e power x1 plus x square, the e power minus x1. So cos hyperbolic x is, hence by addition and subtraction we add these two series, we will have 1 plus x square upon 2x4. So this is a series of cosine hyperbolic x. This is a series of sine x plus x cube upon 3 factorial 5 over 5 factorial. Hyperbolic identities. There are a close correspondence between formula and exponential relation between a hyperbolic function and similar relation between circular function. Consider the following identity: cos hyperbolic square x minus sine hyperbolic square. We rewrite cos hyperbolic x by the formula e power x e power minus x upon 2 square plus e power x e minus x. Just taking the square, so we will have the e power x e minus Here we take the common, write the outside 1 by 4, taking the squares of that e power 2x plus 2 e power x e power minus x, so e power x minus x. So it becomes e power 0, and e power 0 is equal to 1. So we just have the 2. And e power minus x square e power minus 2x. Similarly, minus here, take the square e power 2x plus 2 here, plus minus plus minus e power minus 2x. So 1 by 4, these will cancel with that, and this one is that one. So 2 plus 2 is just 4, it is equal to 1. So cosine hyperbolic square x minus sine hyperbolic square x is equal to 1. This is the basic relation of hyperbolic functions and is analog of the direct with the trigonometric relation. Cosine square x plus sine square x is equal to 1. Dividing both sides of 1 by cosine hyperbolic square x. So we will have 1 minus tangent hyperbolic square. Here cosine hyperbolic square x is divided with cosine square x. We will have 1 sine hyperbolic square x divided with cosine hyperbolic, so that becomes tangent hyperbolic square x. 1 over cosine hyperbolic square x, that becomes sec h square x. Similarly, we divide both sides of 1 by sine hyperbolic, we will get cotangent hyperbolic square minus 1 cosec hyperbolic square x. In this lecture, we studied the circular and hyperbolic function. Uh, so I request you kindly subscribe the channel and like the video as you find more videos on different topics of mathematics. Thank you.